there are a number of graduate student research fellows to encourage you all to apply. Pass around this flyer. It's not huge amounts of money, but can be really helpful. And of course, Anne Marie is the person to see if you free money.
Yeah.
Amazing. You have to encourage people to ask for money. Let's see. Slow. Hello. Welcome, everybody, to today's ITS seminar. I'm pleased to introduce Dr. Sherry Ryan, who is a professor in the School of Public Affairs, and in particular the graduate program in city planning at San Diego State University. Sherry does research on this connection between land use and travel behavior. She's been doing this for a number of years, a lot of it very closely tied to the public health field and focusing on bicycling and walking in particular. So, very interesting topic today. I think it was Einstein who said something to the effect of, if you don't count it, it doesn't count. And, in transportation, we have many decades worth of experience counting cars and evaluating conditions for cars. But as it turns out, we've done very little work on how do we count bicycles and pedestrians as well. And now that we are increasingly interested in trying to understand those modes and promote them, we're realizing that this dearth of data is just a huge problem. Even here in the city of Davis, we have very little data about how much bicycling activity there is. So Sherry has been working in the San Diego region on efforts to do regular bicycle counting and monitoring. I don't know why, but San Diego seems to really be at the forefront of this effort that's spreading around nationally. So counting bikes might sound a bit mundane, but a very important topic, and I'm really excited about hearing about some of this very innovative work going on. So with that, let's welcome Sherry.
I get strapped up here. Oh, I see. Great, thank you so much. Is that volume too high? It's good? Excellent, well thanks so much. Super happy to be here, and thank you for the introduction. So I'm going to be talking to you about a program that we've been working on in San Diego for the past couple years, launching an automated active transportation data collection system in San Diego. And so that has to do with bicycle and pedestrian counting using automated equipment. And so this this effort that I'm going to be talking about today grew out of a collaboration between the County Health and Human Services Agency in San Diego. So the County Health Department, SDSU researchers, and the Regional Planning Agency there, SANDAG, San Diego Association of Governments. So the County of San Diego was instrumental in winning a $16 million grant called Communities Putting Prevention to Work, and they used part of that $16 million to fund this effort. And so there were some real forward-thinking staff, public health professionals at the County of San Diego who understood this lack of data in relation to walking and biking. And so they earmarked about $350,000 from the Communities Putting Prevention to Work grant towards this effort. Kind of snuck it in. It was a little off topic, but it went through, and the CDC funded it. And so we're the lucky beneficiaries of this this pretty robust network of automated bike and ped counters. We're, the funding went directly from the Health and Human Services Agency to SDSU. SANDAG is kind of coming on board. They didn't have any funding associated with this. They like what we're doing. They obviously would have a need for that kind of data. They're doing long-range bike and ped planning, but they're, at this point so far, they're not completely invested in the effort. And so we're working on them, the SDSU and Health and Human Services, working on SANDAG to really get them to take ownership of this effort to support their long-range planning. But that, oddly enough, hasn't entirely happened. So interestingly, SDSU owns this equipment that's out installed in the field. County doesn't own it, SANDAG doesn't own it, the cities don't own it, SDSU owns it. So it's pretty interesting. So why are we counting? Why was the County of San Diego Public Health practitioners interested in counting? They're trying to increase physical activity. What better way to increase physical activity than to integrate walking and cycling and utilitarian travel? So they're looking at the transportation professionals saying, where's your data? How many people are walking? How many people are cycling? And we're saying, we don't know. And, so they're nationwide, really. There's an effort to bring about increased levels of physical activity, increased levels of cycling and walking, especially for utilitarian modes. If we're trying to bring about that change, we need to be measuring to understand those phenomenon so that we can really support and help those changes come about. And so it's all part of this effort to inform the decision making and projects like the regional bike plan that was adopted in 2010 in San Diego. I actually served as the consultant team project manager for that effort. So here we are planning a region-wide network in the complete absence of information on who's cycling where and how many. We have no information on the demand for cycling currently, in the future, and we're doing planning work. And so that shouldn't be happening. But that is what has been happening. And I've worked on quite a few local government bicycle master plans, and all of that work happens in the absence of data about who's cycling and how many and where. So this data can very much inform long-range planning. It can inform travel health monitoring, obviously, but also project evaluation. Before, after, that kind of understanding of, if we build this, what's going to happen, how's behavior going to change. And so we need this data for those reasons, really. We focused in on a automated counting network because we really wanted to have that consistency. I don't know if you're familiar with how bike and ped counting occurs frequently, but often it's advocacy groups that say, we need to do an annual bike count. And they try to recruit volunteers and go out and do some counting, but that's not the way it should be done. There should be some kind of institutionalized, rigorous approach to collecting this data. It shouldn't be an effort that's relegated to volunteers, And so we wanted to achieve some kind of consistency in the data that we were collecting. The automated counters give us really incredible temporal quality of data. We're capturing data at 15-minute intervals, 24 hours a day, continuously. So it's real good temporal quality data that will allow us to look at daily. I feel like is this okay? It's okay? Okay. Will allow us to look at patterns by time of day, which we never had. And then thirdly, we went towards this permanent automated counter system because of the really high level of data accessibility. So the data is being collected by units that are installed in the field, and the data is transmitted daily to an internet-based web server. And so I have immediate access to that data. Local governments have immediate access to that data. So really strong level of accessibility, which means the data is going to get used. And that's been a problem with previous counting efforts. You're out there manually ticking away on a piece of paper, then you got to go back to the office, input that data in a spreadsheet, and then who knows what happens with that data. But this is much more streamlined and integrated into kind of a software that's accessible via the internet. So that's some background. I'll talk about the technology. the siting and the installation, and then just take a preliminary look at the data and some of the applications that we've thought about for using this data. So initially with this program, we did some research about, who are the vendors, what's the quality of these vendors, what's the quality of the technology out there. And so this was about 2 years ago, and we came upon EcoCounter, and they're probably really at the forefront of this industry of kind of deploying equipment on a large scale to collect automated data. And so we're using 3 different technologies. This top left one is called the Zelt Logger and inductive loop. So this contraption is about 10 inches by 12 inches, and that gets installed on the side of the road, and it's attached to loops that are run out into the travel lanes or the bike lanes. So this is allowing for in-street bike counting, which is pretty important. In-street bike counting. The technology on the bottom is a combination of both infrared pedestrian counting and the Zelt inductive loop. So that technology is focused on pretty much bike path installations. So you want to be counting cyclists and pedestrians in a bike path situation. And then the top right there is the Pyro, and that's about a 12-inch by 6-inch contraption that gets installed on a pole pointing at a static background and has an infrared beam, and when the beam's broken, it counts a pedestrian. So that can only really be installed in an urban environment where you have a place to install it. So it's not real good for counting cyclists, obviously. So these are the three types of technology that we had. In terms of siting, so we're looking at the county of San Diego. It's a very large region, 18 different jurisdictions. We have this money. We had to develop a process for siting, where are we going to install these? And so we tried to think about this in a structured way, develop some criteria for siting the equipment that we'd be purchasing, and we basically used these 4 criteria. Geographic coverage, so we didn't want to have the counters all in one jurisdiction. We wanted this to be a regional effort and try to get some coverage in the 18 jurisdictions that are in that county. We wanted to sync up the bike count stations with the regional bike network. So Sandag had adopted a plan in 2010, planned regional bike network covering the 18 jurisdictions. We should site the counters on this regional network, hopefully kind of stimulate Sandag to be interested and invest in the program. But also, as Sandag invests in infrastructure on those corridors, we're going to have before-after data that's very rich and important for understanding cycling behavior. We also looked at the long-range regional comprehensive plan, which identify nodes of high-density mixed-use development in the San Diego region. They're called smart growth opportunity areas. So we also tried to cite the counters in smart growth opportunity areas. So super important that the siting and these data collection points are linked to the long-range bike plan and the long-range land use plan for the region. And so we think that's tremendous benefit for kind of doing performance monitoring and assessing implementation as it happens. The third criteria was that we wanted our sample of count station locations to be representative of the regional bike network. And I have a couple slides on that, but we wanted to ultimately be able to use, we're counting in one location. We want to be able to say something about the level of cycling in another location where we're not necessarily collecting data. So if our sample of count stations is representative of the entire regional bike network in terms of population, employment, income, we have kind of a better framework for using the particular count data collection to estimate cycling demands in along other corridors within the network. And so we did that as well. And then we wanted a siting framework that would allow for some kind of logical expansion. And these first three criteria, in fact, provide that framework. So this map shows the regional bike network. So all of these blue lines are part of the adopted regional bike plan. So it's something like 500 miles of bike corridors.
What's the distance scale?
Yeah, it says 6 miles. So that line is 6 miles. No, 026, I think. 036. Yeah. So you see the regional corridors, the blue lines. I'm not showing on here the smart growth opportunity areas, but a majority were cited in smart growth opportunity areas. So you see the blue dots are where we're doing in-street bike counting. The orange dots are where we're doing pedestrian counting using the Pyro. The pink dots are where we're doing both using the eco-multi. So bike and ped counting on bike path type locations. You'll also see that there's a phase 1 and then a phase 2, which I have on that map as happening in October 2013. And in fact, just this week, that phase 2 is getting started. So we have a whole bunch of other equipment that's getting sent to the contractor to get installed. And so those are all the little triangles that you see, on the map in this area. So at this point, we have 26 sites installed, 15 bike only, 7 bike and ped on class 1 facilities, and 4 pedestrian only in urban environments. And the number of sites is going to grow to about 35 sites total across the region once our second phase is done in a few weeks. So about the representative sampling, what we did was we developed sampling strata by census tract using population, employment, and income. And so this grid, these 3 grids kind of show you how we got to 27 sampling strata using those 3 variables, population, employment, income, divided or categorized into 3 classes. So that ends up giving you about 27 strata, or exactly 27 strata. And what we did was segment the regional bike network, all those blue lines that you saw. We segmented and buffered the regional bike network and looked at the distribution of strata across that regional network. And then we tried to match our count sites to that same distribution. And that's how we tried to achieve a representative sample of the regional bike network. So with our 26 sites, this is how close we got. So you see here the percent of segments or locations of the total, and then you see the 27 strata across the bottom. The orange line is the distribution of strata for the regional bike network, and the blue line is the distribution of strata for the count sites, for our 26 count sites. So you can see there's a pretty strong match. It's not perfect, but a pretty strong match. You can see there's higher levels of strata in strata 4. We can just go back and see what that is. So strata 4, right here. So that would be high employment, high population, and median income. There's relatively high levels of representation for strata 13, which is high employment, medium population density, and median income. So the point being that we don't want to just count in, say, all high-density areas where we would expect more cyclists. We want to also be counting in low-density areas so we can understand the variation in built environment related to cycling levels. And so we needed to have that variation in the built environment and socioeconomic variation as well to really understand what influences what. When I talked about having a framework for expansion, using the strata, using the regional network and the smart growth opportunity areas, we can use that framework to hand pick additional sites. In fact, if we did that, I went through and hand picked another another 30 or so sites and got to about a complete network of 76 sites. And you can achieve a real strong match if you add those sites selectively. So this is kind of the number of units that got installed by jurisdiction. And so there's a total of 35 units in this phase 1 installation that got installed in 26 locations. So in a lot of locations we have 2 units because we're counting in both directions. So you need 2 units at a site. And you can see the mix of technology that we did. So we covered about 13 of the 18 jurisdictions. So we didn't get every jurisdiction, but we got a good number of them. Then to look at some of the pictures, this is a Rose Canyon bike path that connects Pacific Beach and UCSD. And so you can see here the Zelt logger in the ground. I'll just use the cursor. The Zelt logger is installed in the ground, and then the loops are laid across, embedded in the asphalt. So when the cyclist goes over that, triggers a count. And we're getting directional information as well. This is an installation on what we'd call a bike route, class 3 facility. You can see over here the green box installed in the landscaping strip. So it's pretty innocuous, doesn't attract a lot of attention, looks like an irrigation box. And then the loops are run out into the road. So you can see a class 3 installation is kind of difficult because you don't know where the cyclist is going to be, really. But we tried to put them, extend them out kind of midway into the travel lane, hoping to capture a majority of the cyclists. But it's not perfect. In fact, we're doing video recording to try to 2-hour video recordings at each of these locations to try to understand, what percent of cyclists are we actually capturing with the technology. This particular location is there's a 4th and 5th Avenue in San Diego. It connects between Uptown, which is a pretty dense residential neighborhood in San Diego, and downtown. And perfect example of how this data is going to be of benefit. Sandag right now is doing conceptual design for a cycle track couplet on these two roadways. And so we're going to have over a year of before data, and we expect that to be done in the next year or year and a half, and hopefully reinstall these counters when the project is done. We're going to have the after data. So citing the counters along the regional network where Sandag is making quite a bit of investment, or planning to make quite a bit of investment, is really, I think, going to pay off in terms of supporting our understanding of responses to bike facility. This is along Pacific Highway, and this is, I don't know if you suffer from this problem in Davis, but yeah, it's a bike lane in the gutter. So you got the curb, the gutter, and a foot of asphalt. In fact, I just talked to the contractor today because I'd forgotten to tell him, when there's a bike lane in the gutter, we don't want to put the loop in the gutter because the cyclist isn't riding there. So pull it out into the asphalt where the cyclist is probably going to be. And he got it. He understood. So we're hopefully not going to have this. But there's even still pretty good cycling demand along this corridor. It connects between the beach communities and downtown. But this is a Class 2 installation. Here's an eco-multi. This is on the Ocean Beach bike path. And so you got the pyro that's in located inside that wooden block there, with the Zelt installed in the ground and the loops running out. And so with this kind of installation, we're capturing both pedestrians and cyclists. Yeah. Yeah, like a validation study. Yeah, that's what we last summer, we did 2 hours of video recording at each of the locations. And so we got to do some data capture, and that will enable us to understand the error rates. So we suspect there's just plain machine error, but then we're just also missing cyclists, especially when we're doing the on-street counting. There's cyclists that go in the middle of the lane and they're not going over the loop. So, we haven't really gotten to calculating that in a way that I feel comfortable saying, but I'm almost 100% sure that they're undercounting in all locations. They're not overcounting. So we don't have the problem of cars driving over and counting. In fact, I didn't mention that, but the reason, one of the reasons that we also went with this vendor is because it's the only technology that can distinguish a bike from a car. So we're not counting cars. It's able to sense the magnetic field or something like that to distinguish a bike print from an automobile print. So that, if it was counting cars, that would lead to overcounting, but we don't think that's happening. Yeah, okay. This is downtown San Diego, the Pyro, that's infrared technology. And so then on a daily basis, every morning that the data is transmitted from the units out in the field to an automated, to this web-based server. And I'm able to access the data through this web-based software. And it's really phenomenal. I can do all kinds of quick aggregating of the data in a way that just I haven't seen with any other counting technology. So I'm really able to work with the data quickly in a way that's meaningful. So it's kind of difficult to work with a database when every record is 15 minutes and you got this continuous data over weeks and weeks and months. And I can do quick aggregations with this software that's provided. Data downloads by year, by month, weekly, hourly, at 15-minute intervals. Very easy formats, Excel charts, averages, Word documents. So that's a little bit about the program. And next I was going to talk about some of the data applications and what are we going to be using this data for. I mean, one of the most important things is simply to understand the order of magnitude of cycling. And we just had very little information about that. I was mentioning at lunch that I had no idea how many cyclists were on the streets in San Diego, but now we know in some of the lower density areas there's about 30 cyclists per day. On some of these kind of inland cities where cycling isn't a big deal. On some of the coastal cities where more people are riding their bike, about 1,200 average daily cyclists. And so we're beginning to kind of understand the order of magnitude of cycling. We can do some real quick looks at the data and understand usage by facility types. And importantly, we have these temporal patterns to look at. So are there seasonal variations, month of year variations? Are there day of week variations? What are the hour of day variations? And all of these kinds of patterns are really important to understanding travel behavior. We know all of this for driving. We don't know any of this for bike and ped. So pretty important. Before-after studies, obviously, very important application. And then also something I'm really hopeful about is using this data to develop improved measures of health, air quality, and safety, all of which are really needed for the kind of planning work that's going on. So the next slides show you some looks at the data. And so what we're looking at here, which is an incredible output from the EcoVisio software, I can look at an entire year of data. So this is 15-minute increments continuously over the entire year. So this is September to October, and it's average daily, weekend bike trips by facility type. So I can include all days, I can exclude some days. So in this particular look at the data, I excluded weekdays and just wanted to look at weekends. And I'm looking at average daily over an entire year. So this is pretty interesting information. And what you're seeing in the color coding is class 1 in the orange, class 2 bike lane in the blue, and a class 3 bike route in the green. And so in a place like Coronado, which is a pretty high-income coastal community, we're getting on the order of 1,400 average daily cyclists on the weekend. Going down to Escondido, which is a really pretty low-income Hispanic community where we're getting, somewhere around 75 average daily cyclists on the weekend.
Sherry, just a question about that. I mean, it seems like that's
No cyclists. Yeah.
And you're counting 75 a day.
Yeah, on the weekend. Yeah, that is in a lot of these inland communities, people are assuming no one's riding their bike, but we're really seeing that people are riding their bike, and also for the commute trip. We see pretty clear weekday peaking. And so it's probably low income people using a bike to get to work. And, and so that's important information. I mean, they're engaging in behavior that the region's trying to encourage, and they're riding on probably, unfortunate bikes and probably unfortunate facility, taking a lot of risk. But, so it's building arguments for increased investments in these locations for sure. So another trend we see, interestingly, or probably expected, higher levels of cycling on separated facilities. So the big argument, big argument about, do we really need separated facilities? Will people feel safer there? This data at quick glance is showing there's higher levels of cyclists on separated facilities. Why? Because people feel safer there and they attract more cyclists. Yeah. Yeah, they're dispersed. They're dispersed, yeah.
So do you have any
Yeah, that's great. I like that.
I forgot to remind you that very long, complicated.
Well, you're getting at one of the issues. So the question is, if I can paraphrase, when you have a dense grid, cyclists can go anywhere, right? And so if we're in the on-street facilities, cyclists don't have to use the facility. In these locations, cyclists are pulled onto the separated facilities, so they're funneled essentially. So that's a real problem with counting. And you'll see in the next few slides some screen line counting I did because I wanted to understand that same issue. We can't just count in one location if you have a dense grid. You've got to count simultaneously on all the parallel roadways. So we did a little bit of that. But another interesting story from this graph is that high levels of, so these class 2 relatively high speed, high volume roadways are showing the lowest volumes. These are class 3, mainly kind of low volume, low speed residential streets, and those are showing higher levels of cycling than the class 2. So I think that's a little bit of an argument for the bike boulevard concept, getting the cyclists. Basic story here, cyclists don't really prefer to be mixed with high volume, high speed traffic. I mean, it's pretty basic, but that argument still needs to be made clear through data. Yeah, go ahead. Yeah. Or people. We could put people out on corners. Yeah. We did. I did. Also, and yeah, and I think that can work.
To establish where in that grid.
Yep. Yeah, I think that's really important. So the question is using short temporary counts on all the parallel network to establish kind of the level of volumes, the relative volumes in a dense grid. And yeah, I think that's important. This is showing average daily by day of week. So here, again, looking at an entire year of data, average daily for the weekdays and the weekends. So, and I just did this graph for bike lanes, so just the bike lane locations. And you can see, the expected, in La Jolla coastal community, expected weekend peaking. So on Saturday, Sunday, the count goes up pretty high. Nimitz is also coastal. Pack Highway is more commuter, so less peaking on Pack Highway, the Green Line. And then you look at these 3 inland communities that are relatively low income, high Hispanic, and you got peaking around here, Tuesday, Wednesday, and kind of trending down towards the weekend. So we can begin to look at these patterns. We can begin to look at hour of day patterns and really understand the behaviors in a way that we haven't previously. This is a look at the Rose Canyon Bike Path, just 1 week of data in November, and I developed this based on a request from a Sandag staff person who's doing a project on that facility and was getting pushback from Sandag board members saying, why are we investing in Class 1 recreational facility? And we suspected that wasn't the case, but we could look at the data finally for once. And you can see real distinct double peaking on the weekdays, which implies commuter traffic. You're going and you're coming back. You do see on the weekend the typical single peak recreational implying a loop kind of a thing. But he used this data very successfully to argue that this is a utilitarian facility. It's a transportation facility, not just a recreational facility. And so it's kind of applications that we're hoping to use this data for. So we've also been trying to think about, how can we use this data to estimate across a community, across a network, an entire roadway network? How can we use this data to develop estimates of daily bicycle travel? Similarly to what we have as output from the regional transportation models. We have real good information on average daily volumes across networks for cars. Can we do something like that for cycling? And then can we use that information to really develop improved measures of health, air quality, and cycling? So the next slides show you some thinking that we're doing about this. And one of the things that we're exploring is using our understanding from the 24-hour continuous counting of percentages occurring in the peak period, 4 to 6. So using our understanding of how many cyclists, how many of the total daily cyclists are occurring 4 to 6 peak period, and using all of a set of short counts to, along with that understanding of what percent is occurring in the 4 to 6 period, to estimate daily bike volume. So if I know in a particular location that there's 50 cyclists 4 to 6 p.m., I know on average in that area that 15% of cycling happens 4 to 6, then I can calculate at that location the total or the average daily cyclists. And so if I had a real broad base of short counts, I could use this understanding of that peak period percentage to estimate broader daily bicycle travel. And so part of this was inspired just by the work on the regional bike plan, where we have no idea of the relative demand for cycling along these corridors. So this is looking at downtown San Diego and the regional bike network there, and we use students to go do simultaneous short counts. So short counts 4 to 6, straddling for the most part these corridors, the regional bike corridors, to really get a sense of how many cyclists are in the network, because it's pretty important if we're doing this long-range planning. We know that cyclists can kind of go anywhere. We can't just count in one location. So we did all of these screen line counts, and we can use that in combination with automated counters. So we have automated counters where these squares are located. So we have automated counter here, here. So counting in the north-south direction. We have 2 automated counters counting in the east-west direction here. So we have about 4 automated counters in close proximity to all these short counts. And the question we were asking, can we use our understanding of hourly patterns gained through the continuous counting, apply that to the short counts to estimate daily volumes in those other locations? So we took a look at the hour of day trends for those 4 locations near all of those short counts. And we saw a good amount of consistency in the percent of travel during the 4 to 6 period. So that's the 4 counters are all right in this range, 4 to 6, pretty consistent. And in fact, when we looked at all of our counters, we found a good amount of consistency in terms of the percent of cycling in the 4 to 6 period, 4 to 6 p.m. period. So this is a table of all the locations ranked from highest to lowest. Ranked from highest to lowest. So there's standard deviation of 1.9. The average percent of daily travel in the 4 to 6 period is 16.5%. And so we felt, or we're beginning to feel pretty confident that we can use that hourly, the understanding of hourly count and kind of hourly travel to apply to short counts and grow those to daily counts. So these are the percentage of total daily counts, 4 to 6 in these 4 locations. So pretty similar, 16.4, 16.5, 17.3, 18.1. The blue dots are all the locations for the short counts, the 4 to 6 counts. So we applied those percentages to those nearby counts to grow a daily volume or to estimate a daily volume. So that gives us, we're starting to get at a network of counts, a network of estimated bike flows. It's kind of information that we haven't had access to, and it's potentially very informative. Sandig right now happens to be doing planning. So here's the fourth, fifth couplet that they're planning for right now. They're also planning for the east-west corridor. So pretty rich information. This 830 or the higher level of demand on this roadway has been very surprising. And in fact, we've seen that kind of phenomenon in a lot of locations in San Diego where cyclists are actually going on the busier commercial roadway and not staying on the kind of low-speed, low-volume roadway. So we're beginning to see some kind of trends in how cyclists are using the network, which is pretty interesting in supporting long-range planning. So we're able to look at this community and say there's, on a daily basis, there's about 1,260 cyclists moving in the east-west direction, dispersing across the network. It's about 520. And this is pretty constrained network here. There's only 4 linkages that go between uptown and downtown. So about 520 cyclists. And then on those 4 or 5 roadways, north-south in the middle of that North Park community, about 520 daily cyclists. This kind of information we haven't had before, super important for, kind of beginning to look at how we can develop better measures of health, air quality, and safety. Right now, when we try to do safety analysis for bicycle planning, for example, we look at frequency of collisions. And we know that that's a pretty weak measure. If we knew the denominator, if we knew the total number of cyclists there, we could really look at exposure. We could look at risk in a way that's much more informative than just simply looking at frequency of collisions. If we knew the length of an average bike trip we could apply that average length to the average daily bike trips and estimate minutes of cycling. And so we'd done some work sampling from those neighborhoods and found that the average bike trip length was about 9 minutes for some of those populations. We could apply that to the 1,200 and estimate that there's about 35,000 minutes of daily cycling going on in that neighborhood. So this is a real good measure of physical activity and can translate into health benefit analyses that we currently just can't do.
GPS data from
It was, the question was, is the GPS data just from the east-west? No, it was from that entire kind of a multi-community area. Yeah. Other topics that we might be able to address with this data, we could stand out in those same locations where we're doing the short counts and ask cyclists, is this trip replacing a car trip? Do you own a car? Is this trip replacing a car trip? And we could ask them their origin, destination. So quick types of questions, but we could use that to calculate vehicle miles avoided that can translate into real good measures of air quality benefits resulting from bicycle travel. And then the safety issue. I think that's super important that we look at collisions divided by volume and not just frequency of collisions, because it's really just estimating or reflecting demand. We get a lot of collisions in locations where there are a lot of cyclists, so that's not very important. We need to understand, relative to the volumes there, how many collisions are happening.
Is there ever a case when you would divide the number of bicycle collisions by automobile vehicle miles traveled? That's what the state does on their Office of Traffic Safety.
I have seen that. I mean, that's...
Why would you do that?
Number of cyclists hit per vehicle trip. I mean, I think there could be some justification for that. I mean, you have to normalize the collisions by something, either population. I've heard of normalizing by volume, vehicle volume, but not too frequently. But I think the best thing would be to normalize by actual cycling volumes. So if you could estimate networks of cycling volumes, then you could do that calculation. So these are some of the things that we're kind of looking forward to doing. Started playing around with some of these things, but really just focusing on getting the system up and going. And we're getting pretty close. So we really need to secure funding to keep the system going. It costs probably about $28,000 a year to keep the data transmission going and to replace batteries. It's not a big cost, but we need someone to step forward, hopefully Sandag, with that funding. We need to make the data available to the region, to other researchers in the state, in the nation. And really our hope is to get this data into mainstream planning and evaluation, which it's really lacking at this point. And develop a research agenda around this data and kind of move forward in terms of contributing to the literature on our understanding of travel behavior, especially cycling and walking. So that's it. Thank you so much.
We have a good amount of time for questions. Oh, sorry.
Sure. Yeah. Well, these are the actual peak. These are the actual peak period counts. So we stood out there, 3 people out in those locations, same 2-hour period. 137 on University, 25 on Robinson, which is a 2-lane, pretty low speed, low volume, and then 39 on Washington, the high speed, very wide roadway. So. Yeah. Yeah. Yep.
that people are trying to avoid these busy streets,
Right.
but in certain areas they certainly aren't. They're twice as likely to ride on universities than going.
Right. And I think what's happening is that for commercial streets, they're serving as real strong destinations. And eventually the cyclist needs to get to the destination, which in a commercial environment is along that pretty large street. So, and we found that same phenomenon in other locations, like in Pacific Beach, very strong network, but higher levels of cycling on the commercial boulevards. I think they'd be on the parallel roadways, but not so much. So I think it's a phenomenon related to the land uses and they're a real strong pull. That's where if the cyclist is trying to get there, that's where they need to be. Yeah, right. Yeah. And that's where they get counted. Yeah, yeah. It's hard to count cyclists. It's really hard to count cyclists. But I think it's okay. I mean, I think it's okay. It's information, and it's we're trying to push this forward. Yeah, we haven't done those surveys yet. That slide I showed, kind of proposing to do surveys. I think that would be an excellent question. What are the factors that influence your route choice? And I think when you have GPS data of cyclist travel, you can kind of infer that from those paths. And we do have some of that data, but I think if we do surveying at these locations, we'll definitely ask about the factors that influence their route choice. Yeah. I think for the planners I know of who've used this, no, there's a good level of acceptance. I mean, there's going to be some error in it, and there's error in vehicle data collection also. And there's a lot of potential error in vehicle data collection. But no, I think there's a strong level of acceptance and interest in kind of building this up. Sandig? Yeah. Sure. I mean, I think the collaboration was really beneficial, having the county health department with SDSU. I mean, that was pretty phenomenal, and just getting this to the region was pretty phenomenal. But there is some downside when the regional agency that kind of controls all the transportation funding, it wasn't their idea, it wasn't their project. We're trying to get them to buy on to it or buy into it now, and there's interest, but we need this a budgetary allocation every year for the next 10 years. So I think we're making some inroads for sure, but it hasn't quite happened yet. So we have. Yeah. Well, I think there's so much pressure now to be doing bicycle pedestrian planning, and all of their planning speak is about complete streets, is about planning for choice in travel. So if they're going to do all that planning speak, they need to have some data, and I think it's not going to be that hard, and I think we'll be successful in getting them to buy in. That's what we're working on. Yeah. So we need a correction factor for numbers of cyclists we're missing, for machine error, And I'm real interested also in getting a factor for sidewalk cycling, which is part of the number of cyclists we're missing because they're on the sidewalk, not because they're in the travel lane. So
you need some
yeah.
data analysis?
Yeah. And I would absolutely extend that offer if anyone in the room is interested in working with this data. Absolutely, 100% make it available to you to work with. Because we're just coming up on having a year of data in these 26 locations. So there's all kinds of stuff you could do with that data. There's real good GIS built environment data for San Diego. So. I'm sorry. Repeat. Yeah. Yeah, we don't get good mode share information about cyclists from the San Diego model. We get non-motorized trips, so the bike and ped is combined. It's real weak. I mean, they literally don't know anything about cycling behavior, and the model's not. There's no input data about cycling. There's no output data about cycling. But we could try to compare. If we combine bike walk trips somehow, but this doesn't really get us at mode share. It really doesn't. I mean, we'd have to count all modes on a link to get mode share. Really, I mean, we're just measuring one mode, so we don't have good mode share information coming out of this.
But doesn't the Sandbag model have very accurate vehicular numbers? And if you take your numbers, which are actually bike numbers, you've got a mode share.
Along a segment, if you had, yeah, I mean, if you had walk trips, bike trips, car trips, and transit trips, all on the same segment, I think you could develop mode shares for segments. But yeah.
Those several segments you showed that had 500 and 500 and 1200.
Yeah.
How many cars are there in those segments?
We could know that, possibly, yeah. I haven't looked into that, but I mean, if we had good coverage in in car counts, we could estimate that. Yeah, I think you'd need all trips. So you'd need car, bike, walk, and transit. Doing each of the, yeah. Mm-hmm. Yeah. Across that cordon. Yeah. Mm-hmm. Along. Yeah, they're updating it to the ABM. Yeah. Yeah. Right, right. We do anticipate they'll want to use this data for validating their bike model that's being developed as part of that ABM model. Yeah, it's incredibly impressive. It was adopted in 2010, and the board has just awarded $200 million to start design construction on the high priority projects that came out of that plan. So they're moving very aggressively. They actually are bonding to build bike infrastructure, which I don't think has happened. I mean, they bond all the time to do transit and highways, but they're borrowing money. They're issuing bonds to raise that money to build bike infrastructure. So they're getting very serious about it. Very serious about it. Absolutely. These pink lines. So we're super close to downtown. Downtown's right here. So all of these corridors are feeding into downtown, and those are all the high priority corridor segments. So the prioritization, what really fell out of the prioritization was real density focused. So the corridors in the higher density areas are the higher priority corridors, and those are the ones that are going to get constructed. And so, yeah, I have right there the 4 automated counters are pretty nice coverage. Not great, but it's decent. 10 years, $200 million in 10 years. So they're being quite aggressive about it. Estimates about bike volumes? No. I hadn't done anything like that. Yeah, I think some of the numbers are kind of leading to some head scratching for sure. I think that has to get out there. Mm-hmm. Right. This same company, EcoCounter, does have pneumatic tube counters. The Zelt Technologies is available with pneumatic tubes. So you can go lay the tubes out in the bike lane. They're small tubes. They're smaller than tubes used for vehicle counting. And so, yeah, that's absolutely available. In fact, I'm working for the Maricopa Association of Governments doing a regional bike count there, and we're using all pneumatic tubes temporary. We're putting tubes out in 44 different locations to shorter continuous counting, like 2-week counts. So yeah, that's another option for regions. But I mean, there's nothing. I think there's no way to get around the value of having a fixed location, continuous over time. I mean, it's real strong. I mean, I think that should probably be the core of any regional counting program, is to have some set of permanent counters and then maybe do some temporary counting or short manual counting. Yeah, that need to do research projects. Yeah. Right. Not just about the technology. It's creating a network that is justifiable and will support analysis. Right. Yeah. Yeah. Well,
Davis is on staff approved SACOG grant for wayfinding.
Oh.
But it has a component of counters in it. I can't tell you the exact number.
Excellent.
It's been staff approved for funding. It's primarily for wayfinding. It does have counters, and so we may need some help when
Excellent.
that actually gets approved to questions of citing and what makes most sense for
Right.
the road network.
Right. Good.
Yeah,
That's
actually,
fantastic.
To what degree are you involved in these national efforts to develop the national bike
Documentation
Yeah.
or the TC, the TR.
I mean, there's some efforts to kind of systematize and promote all this data collection. It seems like this, your experience with this would be so valuable to other people.
Yeah, I think they know about it, and I'm pretty sure some of those researchers know about it. I haven't had too much interaction with those groups, though. I know Kittleson is involved in that, and yeah, but I haven't had too much interaction with them. I haven't. I mean, we have ped counters out there, but I haven't been to. It's less. Ped travel's less networked. I mean, bike travel is flows on a network, and that's real relevant transportation. But I think we do need to think about how to use that. Okay. Yeah, thank you. Oh, good.
Yeah.
Well, I'm serious. If you want to collaborate and use, I think it would be excellent.
How close are some of those projects to the actual
Construction.
like because you were talking about how they're prioritizing these good urban areas, but are the counters
They're on the fourth. Yeah, that's fourth and fifth. I have two.
are they doing all of it, or what are they doing? I'm doing route choice, some route choice from all that history. I'd be very interested. That might be a little bit. That was Aaron's. Yeah. So it's going to be probably a I'll be here for a couple more years.
They're trying to. Great.
creating like business, like that's the main thing I'm focusing on. It'll be a good excuse to go. Well, take a audit. Record. Use your phone to record video and That all goes into GIS network. Well, yeah, effectively. It's a really immediately goes from it's ready for